In Chapter 6, Section 5, we start getting into circular functions, graphs, and properties. All right, so let's again consider a radian measure in the unit circle. Okay, we define radian measure for theta as theta equals S divided by R, where R is equal to 1 because the radius is 1 in a unit circle, and theta equals S, I should use a cursor, S over 1, or just S. Okay? So what we're going to do now is extend our trig functions using domains that are composed of real numbers or radians. So trig functions with domains composed of real numbers are what we call circular functions. Okay? So we have some basic circular functions. For a real number S, that determines a point and we'll just call the point xy for right now on the unit circle. We have the sign of S to be the second coordinate, or what we call the y coordinate. The cosine of S is your first coordinate, or what we call our x coordinate, and the tangent of some number S is your second coordinate divided by your first coordinate, because don't forget that tangent is sine over cosine, so second divided by first, or y divided by x, provided that your x coordinate is not equal to 0. Your cosecant of S, then, is the inverse of sine, which is 1 over y, provided that y is not equal to 0. Your secant of S is 1 divided by x, again provided that x does not equal 0. And your cotangent of x, or s, I guess, is x over y, provided that y is not equal to 0. Now, let me try and explain this in plain English. If you flip back to your unit circle, or look at the picture of your unit circle, you have ordered pairs that go the entire distance around the circle. At every point on the circle, there's an ordered pair, okay? So for example, I see in the first quadrant we have an ordered pair at 60 degrees. Let's call this 60 degrees. And the corresponding radians are going to be pi over 3. And the ordered pair is 1/2 root 3 over 2. Now, please don't bother memorizing all this stuff. It's not worth memorizing. Just know where to find it and how to use it. Now, what we're saying here is the sign of S is the second coordinate. So the sign, the angle is 60 degrees, We're saying it's the, sign, the y coordinate. So if you look at this y coordinate, the sine of 60 is just root 3 over 2. That's all that tells you, the coordinate stuff. The cosine of s, or in this case, the cosine of 60, it's going to be your x coordinate. So your x coordinate at that point is 1/2, or 0.5. Now, these values right here are the exact solutions, okay? Often, from this point on, we will want the exact solutions. We don't want the approximation. So don't forget that root 3 is irrational. So if you were to divide root 3 by 2, you'd get some long decimal that never ended. You'd truncate it, and then we'd round it. That's an approximation. This is the exact value for the sine of 60 degrees, okay? And that's just a real quick once-over of how to use that unit circle to find exact values. Now, that is, for the most part, the gist of section 5. The text goes through and looks at reflections. You know, reflection across an axis, if you wanted to look at the reflection across the y-axis here, this would be the reflection. So you go 90 and then additional 30. So this would be a 120-degree angle. You know, if you wanted to reflect across the across the origin, you would end up down here. If you wanted to reflect across the x-axis, you would reflect down here. We've talked about reflections before, and the text does a pretty good job of outlining what it is. I just wanted to make sure I touched on how to read the unit circle, because I think the definition here is super wordy. I wanted to make sure you had a practical explanation. There's a lot of really important information in this chapter, including starting to look at the graphs. And the graphs are going to become an important part of our discussion moving forward. So please take a look at those as well. In section 6, we're going to start looking at taking those basic graphs and stretching them, shrinking them, moving them up and down and all around. So make sure you're pretty familiar with what the basic graphs look like. Again, you can start with the basic graphs on the back cover of your textbook.